Je vais faire mon talk en anglais, parce que c'est en anglais, donc, mais tout le monde parle anglais ici.
Yes.
Ok, cool. Alors, mon prénom c'est Jacopo, je suis ingénieur logiciel, c'est ma troisième fois que je parle à ParisJS. Actuellement, j'habite à San Francisco et je travaille pour une boîte qui s'appelle Daeli. Et in my last 8 months, I worked on making secrets better in our company. So, how many backends here? Like, how many full stack? All right. So, you might familiar with Kubernetes secrets, right? So, for who is not familiar with Kubernetes secrets, Kubernetes secrets are a resource in Kubernetes that helps you store and access basically sensitive information in your cluster, right? So if you have password, keys, certificates, you can just like somehow bring it in your cluster through like this type of resource. And the cool stuff about Kubernetes secrets is that that can be mounted as a pod's volume. So a pod is sort of like a container, it's a Docker container. Actually, it's a little bit something else, but a pod can have multiple containers inside, but in this case, in this scenario, we just think about a pod like a Docker container, right? And we can basically mount a secret as a pod, as a volume. So we can just, in our Node application, we just do fs read sync, sync MySQL password, and read the value of that stuff and use it to connect to our MySQL. Otherwise, another way is that we can consume it as a... The problem about Kubernetes secrets is that the data is stored in base64, which is basically plain text, right? In the secret manifest. And so, where do we store our secret manifest, right? So initially, in our company, we stored the secret manifest in GitHub. We had a private repo where we just store all our secrets there. We are on GitHub Enterprise, so it's not a public GitHub, which makes things a little bit better, but it's still kind of not nice. So the motivation why I work in my team to try to improve our secrets is because all our services run in AKS, which is Kubernetes managed Kubernetes in Amazon. And we already use Kubernetes secrets, which were in our GitHub. So the point was that like we were kind of awful at managing secrets. We had no privacy, bad rotation. Actually, we had no rotation at all. The developer experience was kind of like weird, right? Because you wanted to change something, so you had like to update the manifest, you had to kubectl, like apply, and then you have to open a PR to update the certificate. It was a little bit weird. And basically, it was kind of ugly, all this stuff. And yeah, it's not hard to do better, actually. So we start working on, like, we start thinking what we want to achieve with the further work that we're gonna do, and basically want to manage secrets securely. And because we are in Amazon, there is something called AWS Secret Manager or System Manager, which can be used instead of just having stuff stored in GitHub. We want to have transparent rotation, right? We want to be able to update and rotate our secrets without that our application cares about this logic. We want to sort of have like our code, our shitty application not be able to access the secret provider. And basically like the main point, one of the key stuff that we wanted was no application modifications. So right now we use Kubernetes secrets that were mounted as a volume, as a pod volume, and we didn't want to change that. We didn't want to change our application to sort of like eventually fetch secrets asynchronously from Secret Manager on boot. So, whatever. So the solution is Kubernetes external secrets. And this is a project that currently is open source. I'm the main contributor. We just open sourced it yesterday. And Kubernetes external secrets basically represent an external secret as a new Kubernetes resource. And we do this using custom resource definition, which are resources in Kubernetes that allow you to extend the Kubernetes API. And basically, we create external secret custom resource definition, and we implement a controller to support the external secret API. You can guys check the repo out and go through the code to kind of understand a little bit better the implementation, but I can go through after this. So this is what external secret looks like. So we have a bunch of metadata stuff, and then we have like the name of the external secret. In this case, it's a law service, and we have a secret descriptor. And that's the key part, right? We specify where to get that data for that secret property. So in that case, the allow secret, the password property, we say that we're gonna get it through secret manager, and the key in secret manager is allow service-password. And what the project does is, what the controller does is that it gets the secret, external secret, and he converts it, basically, he declares, he fetches the data from the AWS Secrets Manager based on the metadata that we specify and the external secret manifest, and it creates in Kubernetes Kubernetes secrets, right? Which is basically what we already used before. This time, we actually stored in GitHub that manifest, whereas no data in base64. It's just a bunch of metadata that tells the controller where to get the data from, right? And this is going to be created in the cluster, but it's not stored anywhere else. So this is an example how to use Secrets Manager, right? So that's me, that user there, or maybe you tomorrow. And we have the secret data in AWS Secrets Manager, which has a very simple interface to do that. And then we create an external secret, and we just kubectl apply because it's like just another resource. It's just that it's something customized. So we push that into the cluster, and the external secrets controller, which is available on GitHub, and you guys can install in your cluster, basically keep polling external secrets, and when there are new external secrets, is gonna basically take all the data all the metadata contained in the manifest of the external secret, and is gonna contact AWS Secrets Manager to read the secrets data. And finally, it creates the secret object in the cluster, and your pod can access the secret, can mount the secret as a volume or consume it as a variable. So some work that we want to keep going and we want to do in the future for this open source project is that we want to sort of make the access control better. Sort of like right now, there is not actually any access control. Like once you deploy the controller in the cluster, the controller can somehow access to all the namespaces. And tomorrow we want to eventually restrict that per application or per organization. And one of the other things that we really want to do, and it might not be open source, but it's something that we still want to do, is that today we use cloud. We have our own backend to generate SSL certificates, right? And how we do now is that we generate our certificate, we download it on our machine, and we upload it in Secrets Manager, and that's how we push certificates into our cluster. tomorrow, eventually, we want to avoid that process and get the secrets directly out of our custom backend. So the idea is basically to extend to other backend side, and that can be like SQL, it can be Dino, it can be wherever you guys want to store your secrets. Currently, it supports AWS System Manager and Secrets Manager, but really the idea is to extend that to any third-party backends. So there are a bunch of other work around. There is this project that encrypts secrets and stores, like, again, these slides are available. If you are interested in this subject, you can go and check out these resources. So I want to just, before switching to the demo, I want to just say that there is this new repo in the Node.js organization, which is packet maintenance. And it's a new repo you can add yourself in, and it's basically a discussion around how we can help, basically it's to help getting Node.js models organization better. And you can contribute to that. And the VP of engineering in our company, it's really involved into this, so I just want to mention it. And eventually I'm going to get a promotion for that now. So yeah, this is it. I'm going to show you a demo because I think that's what's best. So here is, do you have time?
Oui, mais plus gros.
Okay. Alors, okay, so this is the repo, and I already have it cloned in my computer. It should be good. I hope that people down there can still see. I can try to put this full screen. All right, so I'm gonna run the controller locally as a development in development mode, but it will work the same if it runs into the cluster. So I have Minikube running. Minikube is like a tool that emulates like Kubernetes clusters, but locally. So I already have that running. And I'm gonna authenticate to my authenticate to Amazon to get the credentials. That should really be done. Does it want my MFA? Yes. Corporate policy. So much shit. I need to go through the window. Oh, I was in plane mode, that's why. Alright. That should be good. Alright, so now what I'm gonna do is that first of all, I'm going to start a controller. Again, this is run locally outside the cluster, but it can run into the cluster as a deployment. And there are all the instructions on the GitHub for how to run this. And so the next step is that I'm going to add the data in Secrets Manager. I already created the data. As you can see, the last time that this data got access is tomorrow, and after I'm gonna do my demo, it's gonna be today. So again, it's like secrets name, hello service password. The password is 1234, and you can guys see that kubectl get external secrets. There are no external secrets. I haven't had it yet. And I can do secrets. And there is just the default stuff from Kubernetes, right? So the next thing is I'm gonna deploy this, right? So it's my external secret manifest. Example, a little stuff. All right. So it's been created. And now I can get external secrets. It's there, right? So it take. Oh damn! 404. What's that? Fail to fetch external secret 404. Let's wait a little bit. All right, it worked. So spin up the pod. Yeah, I don't know why I got 404. Some shit. Puff. So yeah, it fetched the stuff. Start the poller, run the poller, fetch it. So right now, I should have my secret, which I swear to God, I tested like before doing this and it was working. Fetch the secret property. I'm calling the secret. I think I know why. I know why. It's because it's this bash profile crap that I have to. Damn it. Source bash profile. It doesn't sometimes get it. Use AWS, so I have to block from him again. It's because it's running locally and it's trying to get my secret stuff, my AWS keys, and it's just a nightmare. All right. Yeah. If it doesn't work, just pretend it worked. Speeding up the poller. So this should take like 10-20 seconds. Fetching property, creating a little secret. Yeah, it worked. And now, if I do secrets, you got the secret there, right? So you can. Just to show you that actually works, I'm gonna give CDL describe secret hello service, and I should have the password data, which is of course opaque. It doesn't show it, but yeah, the password is there. You can see that the property it's alive, and yeah, I think that's pretty much it. So, juste, je reviens en français. En fait, si ça vous intéresse, vous pouvez, il y a un petit lien, Join on Slack. Vous pouvez nous rejoindre notre GoDaddy.org et discuter de ça. On a aussi des autres trucs qu'on travaille en ce moment, plutôt cool. Si vous êtes sur du Kubernetes et vous faites beaucoup de Kubernetes, on a pas mal de projets en ce moment pour du Kube. On a un Kubernetes Client, qui en fait c'est une module en Node. En fait c'est un client Kube, ça wrap en fait le kubectl, mais c'est pas du wrap autour du kubectl, c'est complètement fait en JavaScript. Et je suis contributeur sur ça, et il y a un autre projet qui s'appelle Terminus, et c'est pour gracefully shutting down your cluster. Sorry, your pods in your cluster. So voilà, c'est tout.
Est-ce qu'il y a une
Merci.
question ?
Merci. qu'il y a des questions? Est-ce qu'il y a des questions? Ouais.
Tu nous as montré le manifeste du secret, du external secret, mais où tu décris où ou comment trouver le secret.
Ok, attends, je vais. Ah, ça. Donc, prends son temps. Okay. Donc, en fait, secret descriptor, d'accord, c'est une propriété. Et après, on va dire le type de backend. Aujourd'hui, le projet supporte deux backends. Secrets Manager et System Manager. C'est deux services de AWS. Donc, System Manager, il y a un truc qui s'appelle paramètres. Ça fait partie de System Manager. Et en fait, c'est une Key Value Storage encrypted. Et après, il y a Secret Manager. C'est un autre service un peu comme Vault, mais c'est la version de AWS. Et après, on a une liste de propriétés. Et ça, en fait, ça correspond à la même chose que tu mettrais dans un secret Kubernetes traditionnel. Key value, ok? Donc, le nom de la propriété que tu vas avoir dans le secret Kubernetes, d'accord? Name, password. Et tu lui dis la clé, ton secret manager, où récupérer la valeur pour cette propriété-là. Qu'est-ce que c'est ça, en gros?
Et donc la connexion vers, peu importe, cette base donnée, elle est déjà décrite quelque part.
On utilise le SDK AWS.
Voilà, d'accord.
En fait, dans notre projet, par exemple, le backend, Secret Manager. En fait, là, on y injecte. Bon, après, ça ne se voit pas beaucoup parce qu'on fait toute la dependency injection. Mais en gros, cette backend class, il va recevoir un client pour interagir avec Secret Manager. Et ce client-là, c'est une classe qu'on la prend de la SDK AWS, quoi.
Et ça, l'accès à ce SDK, il est toujours.
Tu parles des API clés?
Oui, il est ouvert à partir du moment où ton code est up.
Mais attends, là, tu parles de les clés de l'API key?
En fait, la question est est-ce que j'ai besoin quelque part dans le projet de préciser une clé, un secret pour accéder à ce.
Ah oui, tu spécifies. En fait, de ton pod, pour avoir accès à AWS Secrets Manager, quand tu fais ta requête, quand l'SDK fait ta requête, quand tu initialises ton client, normalement, tu lui passes les AWS Secrets and API Key. Après,
oui, c'est juste
ça,
l'API Key.
Oui, c'est l'API Key d'Amazon qui te donne Amazon. Après, vu que ça tourne dans AKS, tu n'as pas besoin de ça parce que dans tes machines AKS, il le passe comme une variable d'environnement et l'SDK Amazon, il le lit de tes variables d'environnement. Donc, en gros, tu ne configures pas de clé, quoi. Quand ça tourne en AKS et tu utilises Secrets Manager, il n'y a pas besoin de clés. Parce que tout c'est dans Amazon, et Amazon, ils ont fait en sorte que tu ne t'occupes pas trop beaucoup de la configuration. Mais sinon, en gros, là, là, en fait, on va déployer on va créer un chart Helm. Après, on pourra installer ça directement avec Helm. Ouais, ça charge pas beaucoup. Internet. On va voir si ça marche. Mais en gros, dans tes paramètres d'initialisation de le contrôleur, si tu as besoin de spécifier une clé d'accès Amazon, tu peux la passer. Mais en réalité, quand on va créer le chart Helm, quand tu fais Helm install Kubernetes External Secrets, tu pourras lui passer AWS key égale et il la passera avec l'installation. Mais si tu exécutes ça sur un cluster EKS, il la prend automatiquement dans les machines. Ça fait besoin. Est-ce qu'il y a des autres questions?
Juste pour ça, il n'y a pas d'équivalent avec sur GCP, c'est juste sur Amazon Web Service.
Alors, je ne connais pas trop GCP. Ils ont un Kubernetes Manager, c'est ça. Après, je ne suis pas sûr qu'ils ont un système pour storing secrets. Mais rien, ça t'empêche d'utiliser Secrets Manager depuis ton cluster Amazon. En ce cas-là, il faut spécifier une clé Amazon, parce que sinon, ça ne marchera pas. Parce qu'en fait, quand tu te connectes de ton GCP, il n'a pas les accès sur du AWS. Mais quand voilà. Mais dans ce cas-là, tu pourrais dire, j'utilise du Secrets Manager sur Amazon, et après mon truc tourne sur du GCP, pas de problème. Il faut juste donner la clé pour avoir accès à System Manager. Secrets Manager.
Peut-être une dernière question. Non.
Combien de gens ont compris? Ouais, c'est cool.
Ok, ben merci.